we're gonna start the second part of our lesson, similarities. I'm gonna deal with the areas and volumes. Okay, for the given example here, they give me two triangles and the two triangles are similar and they give me that the scale factor equal to 3. I want to find the missing two sides in the other big triangle. This means if I multiply 2 by 3, I'm gonna get this side, so I'm gonna get it 6 centimeters. And if I'll multiply 3 by 3, I'm gonna get this one equal to 9 centimeters. Okay, so if I'll compare the sides together, I'll know that the scale factor equal to 3 because 6 divided by 2, it will become 3. So, and 9 divided by 3, it become also 3. So when I compare side to sides, so the scale factor will be 3. Now, I need to compare the areas. We know that the area of the triangle will be half times base times height. So this is the area of the triangle. So if I want to find the first area, I'm going to say half times the base times the height. So I'm going to get it equal to 3 centimeter squared because it's an area. And here in this case, if I want to find the area, I'm going to say half times the base, which is 9 centimeters, times 6, which is the height. And I'm going to get the answer equal to 27 centimeters squared. When I compare area to area, I will find that the scale factor will be, it was a 3 and it will become 27. So 27 divided by 3 to get the scale factor, I'm going to get it equal to 9. What will happen to the 3 to get it 9? If you can see, I'm going to square the scale factor to get the scale factor of the area. And this is our first note for today. This means if I want to find area 1 over area 2, I'm going to put the scale factor to the power of 2. Did you get it? But if I want to compare side 1 over side 2, I want to keep the scale factor as it is. Okay, so this is the first part of our lesson. Okay, so this is another type of questions also. They give me two trapezoids here, and they give me that the length of this side in the small trapezium is 6 centimeters, and the length of this side is 2 centimeters, and the height is 4 centimeters. And they give me in the second trapezium that this side is equal to 6 centimeters, and they want me to find the area of the second part. As what we said before, we need to compare the areas, so I'm gonna find the scale factor and make it to the power of 2. But before this, if I want to find the missing area here, we don't have any another side we can use it with the scale factor. So what we're gonna do here, I'm gonna find the area of the first shape. We know that the area of the trapezium will be half times base 1 plus base 2 times height. So in this case, I'm going to say it's half times base 1, which is 6 centimeters, plus base 2, which is 2 centimeters, multiplied by the height, which is equal to 4. So in this case, the last answer, it will become 16 centimeters squared because I'm talking about the area. Now, I know that the scale factor is this side 6 centimeters over 2, which is equal to 3. So in this case, this is the scale factor of the sides. So the scale of the areas, it will be 3 to the power of 2, which is equal to 9. This means if I'll put A2 over A1, this is A2 and this is A1, what I found already at the beginning, I'm going to name it A1. I'm going to say it's equal to 9 because it's the scale factor of the sides but squared. So I'm going to say now area 2, which is I need to find, over area 1, what I found already, which is equal to 16, it's equal to 9. Now, by making the cross multiplication, I'm going to get area 2 equal to 9 multiplied by 16. 9 multiplied by 16, which is equal to 144. So this is the area of the second shape. Okay, another way to find this one, we can use the scale factor to find the missing side. I can say 2 to 6, and this one 6 2. Then find the other side, then find the height, and also calculate it for the area too. Thank you. Okay, as what we got before, that if I want to find area to another area or compare area to another area using the scale factor, I'm gonna make the scale factor, but remember, it's to the power of 2. What will happen if we have 3D shape and I need to compare the values together? So in the first one, they are telling me at the beginning that they are similar shapes. So I want to find the first volume and compare it to the other one. So in the first volume, we know that the volume of the cuboid, volume 1, let's say, it's equal length times width times height, which is equal in this case to 3 times 4 times 2. And in this case, it will become 24 centimeter. Remember to make it cube. And in the second shape, volume 2, I'm going to get it 12 times 16 times 8. And using the calculator, I'm going to get the answer 12 times 16 times 8. And it will become 1,536 centimeter cube. Now I need to compare the two volumes together. If I'll say volume 2 over volume 1, I'm going to get 1,536 divided by 24, which is equal now to 64. Type. I need to find the scale factor of the two shapes. The scale factor of the two shapes, it will become, let's say, side over another opposite side. So it will become the scale factor of the sides equal 12 over 3, which is equal to 4. So what will happen to 4 to get it 64? We know that 4 to the power of 3, it will become 64. So this means if I want to compare now volume to another volume using the scale factor, I need to make it to the power of 3. So as a note for what we did till now in part 1 and part 2 of our lesson, we're going to say that side 1 over side 2, it's equal to the scale factor. Area 1 over area 2, it's equal to the scale factor to the power of 2. Volume 1 over volume 2, it's equal to the scale factor to the power of 3. And this is what we're going to use to find the missing part. Now I need to apply this on the cylinder. Let's say if we have this cylinder and they give me that the height of this cylinder equal to 4 centimeters, and they give me that the radius of this cylinder will be 2 centimeters, and they give me another cylinder, let's say, and they give me only the radius of the cylinder equal to 10 centimeters. They want me to find the volume of this cylinder. So this is the missing part. Okay, so I need to find first of all the first volume. The first volume of the cylinder, volume 1, it's equal to pi r squared multiplied by this h, because I need to take cross section, which is equal to the circle, and multiply it by h to get the volume. So in this case, volume 1, it will be pi r, which is given for us 2 centimeters squared, multiplied by h, which is equal to 4. So in this case, I'm going to get 16 by, and you can use the calculator to multiply 16 by and get the answer, which is equal to 50.27 to second decimal place. Remember to put the unit here, centimeter cube, because I'm talking about the volume. In the second volume, I don't know how to use it. This is what or how to find it. This is what I'm going to find actually. But I have radius given for us here. So I can apply now my similarity rule saying volume 2 over volume 1, it's equal to the scale factor to the power of 3. So in this case, volume 2, what I'm going to find over volume 1, what I found, which is 50.27, it's equal to the scale factor, and the scale factor, I'm going to get it by dividing the radius over the radius of this shape. So it's equal to 10 divided by 2, and all of this to the power of 3. We know that 10 divided by 2, it's equal to 5, and 5 to the power of 3, it's equal to 125. So volume 2 over 50.27, it's equal to 125. And by using the cross multiplication, I'm going to get that volume 2 is equal to 6,283.75. Thank you. Now I will continue with you doing the assignment question, what you asked me to do, which is a cylindric glass has a radius of 3 centimeters. So we have cylindric glass. I'm going to draw it here. The radius of this cylinder will be 3 centimeter, and the height of this cylinder, it's equal to 7 centimeters. Okay, a large cylinder jar. Now another jar, let's say we can imagine it. Okay, a large cylinder jar full of water is similar shape to this glass. So it's another cylinder here. The glass can be filled with water from the jar exactly 216 times. So if I have the volume of this glass and the volume of the jar, I can quickly say that the volume of the jar will be 216 times the volume of the glass, because I need to fill 216 times the cup to get all the jar empty. So in this case, if I say volume of the jar over volume of the glass, I'm going to get it equal to 216. And as what we said before, if we have volume over volume, I'm going to say it's s to the power of 3. So it's the scale factor to the power of 3. And this is what I'm going to use now to get the scale factor. So if 216 equal to the scale factor to the power of 3, and if I want to find the scale factor, I'm going to take the cubic root of this one. So in this case, this side will be equal to 6, or the scale factor equal to 6, sorry. So this scale factor, what I'm going to use to find the missing part. Now I need to compare the radius, which is given to me, with the new radius, what I need to find. So I want to find the radius of the jar. So I'm going to say radius of the jar over the radius of the glass, which is equal to 3. It's equal to 6. And by making cross multiplication, I'm going to get the radius of the jar equal to 18 centimeter. And this is the first part what I need to find. I'm going to go now for the height. Also, height of the jar over height of the glass, it will be 6. According to this, height of the jar over 7, which is given in the question, it's equal to 6. According to this height of the jar, it will become 42 centimeter. And that's it. This is what I need to find in your homework.